Hello everyone, my name is Ongshu Vikash Mondol and my ID is 377516. Now, in our advanced data management project, we wanted to design and implement a robust database solution for the Bankstown Candy Store, which is a small family shop that still runs through paper logs. In our project overview, as we have mentioned, that it is a small family shop that still tracks the whole stock sales with paper logs, which often causes stock errors, late reorders, and no clear view of the sales trend. So our project actually replaces all these manual methods with a database that keeps the inventory and the supply data in one place and makes the replacement faster and more accurate. Also, here we build the database schema for the database in third normal forms so the store can add features later like loyalty programs or deeper analytics or a graph database, which is our requirement for the course. Now, in this slide, you can see that how the store actually currently manages the sales information. On the left, there is supplier receipt. That's all the record they have of the items bought in. And on the right, there is the end of the day sales. Together, they form the main sales record, but neither links to the inventory or provides the analytics, which is why a proper database is much needed here. Now, to solve these issues and build accurate and useful database, we started by reviewing all the paper documents from the store, like supplier receipts, sheet of summaries, and staff notes. We also had meeting with the manager. From all this, we extracted all the key elements, and then we grouped them loosely into table list, ready for further modeling and normalization. Now, in this slide, you can see our first version of the model created right after analyzing the receipt and each of data. We group the related fields into basic entities like sales, product, supplier, these things. And at this point, we also sketched rough links between them, but without worrying about any rules or normalization. The aim was for this was to simply visualize everything in one place before refining. And the next slide, we actually applied all the three stages of normalization to remove duplication and hidden dependencies. This actually gave us well-structured reviews ready for relational implementation in the next step. So for the next step, our next commentator, Anusha Mujumdar, will join. Thank you.
Hello everyone, my name is Anusha Mujumdar. My ID is 390170. I am presenting this slide. This is the screenshot of yard diagram. Here we use some advanced modeling features like weak entities, qualified association and specialization. This is the this is the full year diagram of our project. Here we use two weak entities, that's our cell line and delivery line, and we also use qualified association, that is between cell. This is the cell entity and this is the account. Qualified association is between cell and account. And last we use specialization. um, this is the employee class, and employee class inherit two subclasses, that are cashier and manager. Both are depending on employee class. Specialization is a way to represent inheritance or subclassing, where a subclass entity is divided into subclass based on specific attributes or roles. And our next slide is this one. This is the screenshot of UML diagram. Here we use some features like composition, inheritance, qualified association or class, and constraints. Composition is shown by field diamond in UML diagram, and inheritance is noted by a hollow triangle and UML. Specialized employee into manager and cashier. And then qualified association, the sale and account logged by relationship users. And last one is constraints, that is stock cannot go below zero, ensuring inventory consistency. That's all my parts. Thank you.
Hello everyone, I am Mushahid Ahmed. I will walk you through the key features of our SQLite schema and its operational capabilities. Let's start with the SQLite schema highlights. Our database is designed with clarity and precision to reflect the store's operational needs. The sale in table includes a nullable account ID, which is foreign key, which allows us to support guest purchases without recurring customer accounts, ensuring flexibility for all transactions. The employee table incorporates a role column to distinguish between managers and cashier, enabling clear role-based access and responsibilities. The schema mirrors our enhanced entity relationship design, capturing weak entities, qualified associations, and role mappings to ensure robust data relationships to align with the store's operation. Currently, our SQL use cases empower Bankstown Candy with actionable insights. Key queries include real-time stock checks to measure inventory level instantly, which we can show on the SQLite DB database. So if we execute the SQL queries, then we will see that our current stock, that is less than 200. New by category analysis helps identify top performing products, guiding marketing purchasing decisions. Supplier analytics provided metrics on performance and efficiency, optimizing our supply chain. Together, these queries enhance decision making and streamline operation, giving Bankstown Candy a competitive edge. Also, if we want to analyze the customer analysis, we we can also show that on the SQLite DB. Here is one query for customer analytics. Yeah, we can see that this query is told us that the customer who purchased more than average. So if we just execute this, we will find uh, 4 customers. Summary: our database design and SQL capabilities lay a strong foundation for efficient inventory and sales management. They provide the tools needed to make data-driven decisions and support optional excellence. Thanks everyone.
Hi, I am Tairat Khan. I'm presenting these slides. Now let's highlight the key takeaways from our project. First, our database design ensures clarity and the relationships between entities are well structured and easy to understand. Second, we have enforced referential integrity through constraints which prevents errors and keeps the data consistent. Third, the system is designed for scalability. This means it can handle growing amounts of data as the Candy store expands. And finally, the database offers robustness, making it resilient against inconsistencies and operational errors. Together, these points demonstrate that our design is not only practical for today, but also adaptable for the future. I think this is a good idea, and now, I'm going to present conclusion. In conclusion, the digital inventory and sales management system provides major benefits to the Bankstown Candy Store. It improves efficiency in both inventory management and sales process, reducing manual errors and saving valuable time. It also supports better decision making through data driven insights and giving store managers clear visibility of sales trends, supplier performance, and stock needs. Most importantly, the solution is scalable, so it can grow with the business. Overall, this system sets the foundation for stronger operations and gives the store a competitive edge moving forward. And now, this is the final slide, which is future work. Looking ahead, our next step will be the implement the design into a graph database. As required by the course, this will allow us to explore relationships between entities in more advanced ways. In the future, we also plan to develop a fully usable system built around the final database so that real users can interact with it in a practical environment. Finally, we aim to add a user-friendly interface and explore scalability improvements, ensuring the system is easy to use and ready for larger datasets. These future steps will transform our design into a complete real-world solution. Thank you all.